All right, let's start. Hello, everybody. Welcome to this overview of AWS data solution. A little bit about myself. My name is Jim Shan. I'm a long-time data warrior, long time, longer than what I want, what I would like to admit. I have been working on data solutions and data technology all my professional life. Right now, I'm an AWS data architect. I build data solutions for the companies using AWS services. I'm also a adjunct faculty in Columbia University and CUNY. I teach relational database and SQL. Also, I have multiple AWS certifications, including the big data certification, data analytics solution certification, database certification, and the machine learning certification. In addition, I also have solution architect certification and network and security certifications. I also have some certifications from Google and Azure, Microsoft Azure. So something about myself, about what I'm working on and how familiar I am with AWS. Let's start talking about the data solutions. So when we talk about data-related services, not necessarily related to AWS, any data solution need to include the following part. First of all, you need to have a place to store your data. Your data has to be somewhere before you can process them and before you can provide the solution. So data storage is the number one thing that we're going to consider when you have a data-related service. Just because you have data storage doesn't mean that you will have data, right? You need to collect data from somewhere. Data systems generally don't generate data on their own. They need to collect the data from somewhere else, anywhere, like online shopping, or like insurance processing, or like online game, something like this, right? Data is everywhere. You just need to collect it and store it. But once you store the data, you need to process the data. For example, once you have a online shopping order, generally you need to divide the order into smaller pieces and send that to different department. Your financial department may be needing the credit card information or transactional amount for their profit or loss calculation, but they don't need the customer's address. Whereas when you send the information to the warehouse, they need the customer's address and the item description in order to organize the shipping, but they don't need to have the credit card number. So these are like when you split them, and eventually you may also need to organize to combine them together again, but that's a different story. In general, you need to process the data using some compute power. And finally, you need to manage the data. Data management such as, what data do I have? I have the order data. I have the credit card information. I have the customer's address. Then out of all this data, who can access that? Financial department cannot see the address, but they can see the transactional amount. They can see the credit card. And the warehouse can see the address, but they cannot see the credit card information. So these are the things that you need to manage to control the access of data and to control the flow of the data. These are the data management side. And finally, you have all the data ready and organized. You need to analyze them and providing some visualization. Just like if you are a weather forecaster, you have all the temperature information or rainfall information. You need to present them to whoever needs this information. You cannot just tell them a bunch of numbers. Nobody can digest that. You need to draw this in a map. Possibly when it's hotter, you will draw it as a red. Or when it's cold and have a snowfall, you will draw some blue stuff there so that people understand what's going to happen. This is what we call analysis and visualization. And in this part, in this domain, recently, a very important trend is artificial intelligence and machine learning, that people are using different machine learning algorithms to help them to do more analysis and visualization. This is something that more and more becoming its own domain, but still, as an old data warrior, I still place it under analysis part. All right, so this is the AWS Management Console of my account, and you can see that it starts with the recently visited services. It's just for my convenience. You can see what for my convenience. You can see what I recently accessed. And here it is the session of all services. You can see there are a whole bunch of services that AWS provide, and also AWS provides some solutions, which is combination of services. All these services, not all of them are related to data processing, only a part of them. So I'm listing, you can see these three graphs, three slides. I'm going to show you some domains that's related to data processing. The number one domain is compute. No matter what data comes in, you need to do some processing, and this is where you do it. EC2 is the virtual machine that AWS provides you. Lambda is the function for serverless function. And then we discussed about storage. You have the object storage and the file storage. Another part of storage is what we call the more organized, managed data storage, which is database. You have the relational database service, RDS, you have DynamoDB, and a whole bunch of them, others. And then you have analytics. Analytics including like Redshift, Athena, EMR. We will cover all these later. Right now, you just need to know that we have database domain and analytics domain. We also have a migration domain where you will transfer external data into AWS. And finally, we have this machine learning domain where you can see there are so many services that I cannot even list them in one PowerPoint slide. But all these services are not created equal. Some services are more important than others. So here is a solution, data solution chart that I created, listing some of the most important services that you will be using in creating a data solution. To the left, we have IAM, which is the identity and access management. It controls security. Security is often overlooked, but it's one of the most important thing in any data solution. You don't want your data be exposed to anyone else that you don't want them to have access. Unfortunately, this is usually an afterthought. You only think about security when your name is in the data breach report, right? So I'm not going to cover security in this presentation, but you need to understand the importance. That's why I still listed here. Then we have storage, S3, starting from top, S3, DynamoDB, RDS, and we have a series of compute powers, EC2, Kinesis, and the Internet of Things. They will collect different data, store them in our storage. Then we will use different tools, EMR, Glue, Lambda, to process the data. And the result of processing usually will be saved in some data storage too. So you see RDS again, you see S3 again, but these are well-formed data. They are not raw data anymore. And we have a Redshift. You have everything stored. You will use Athena for analysis. You will use QuickSight for visualization. And you will use SageMaker for artificial intelligence and machine learning. And finally, if your data is like historical data that you don't need to use, but for some reason you need to store them. For example, like if you ever heard of Sarbanes-Oxley, it's a US regulation that requires large and medium firms to store their data for 7 years. 7 years of data, if you don't need them, you will save them in something called the Glacier, which is an archiving service. Okay, so these are the services involved in the solution, and these are the general processing flow of a data solution. We are going to go through all this in overview of all this in this session, in this presentation. First of all, it's a data source. Data solutions generally don't generate data themselves. Instead, they will receive data from outside data source. And the most common and most traditional data source is what we call transactional system, like like when you do online shopping or brick and mortar shopping, your transaction will be recorded by some point of sales or POS system. This is the most typical transactional system. Or when you file an insurance claim, the insurance company will receive a claim with line items. This is a typical transactional system too. Transactional system can be done either using specialized system machines, or they can be applications running on a AWS EC2 machine. In the recent years, we also see there are what they call software as service or service as service platforms that provide you with a transactional power. Like in Salesforce.com, you can build your own transactional system and they will generate data. These data can also be imported into AWS for you to use to utilize. And another very important trend is Internet of Things. We are seeing more and more usage of Internet of Things, like sensors. For example, all the sensors in the car manufacturing floor, right? There are so many robots. There are so many parts moving. All this can be collected using sensors and give you a good idea on what your factory floor is running. Or like Uber or Airbnb, you can see everywhere where your taxis are, where your cars are, or how your Airbnb hotel is occupied. And you also have home intelligence or smart home solutions like AWS Alexa. Each one is a smart device that can send out information. All this information are what we call Internet of Things, IoT. And this is recently is a very important, very hot topic, how to build the IoT solution and how to utilize the data. But so far we talked about so much about web services and data source. But what is a solution? Solution is not one service. It's not one project. It's related to data source. For each and every data source, you need to find the best tool for collect data, process the data, store the data, and utilize the data. You need to find a tool and tools, plural, tools, integrate these tools together. This is what we call a solution. It's not one single service or two or three separated standalone services. It's services that work together on a certain type of data or multiple types, multiple data sources to make them useful. So next 3 slides, we pretty much cover some general theories and terminology. Each slide of them is a topic of a separate presentation. So I'm not going to cover them, but I do want you guys to see these are the information that's going to be very helpful if you want to have a good understanding of a data solution. Like there are different data types, database types, and they have different usage scenario, right? There's relational, non-relational. What are they, and what they are used, where are they used for? And there's something called ACID, which dealing with consistency of data. If I write the data into the system, how long will it take before you can see it? If I write it to, if I submit the order, how soon can my order processing department, can my warehouse see the order? For a lot of companies, this may be like 5 hour, 6 hour. So these are the consistency level. And there are also something called cap triangle. Cap triangle is a theoretical model of distributed system. The consistency between different nodes, the availability of nodes, and the partition tolerance of the whole systems, right? So we are not going to talk about them. As I said, each of them is the topic of one whole 1 hour presentation. But these are the topics that you maybe want to research on and look into if you are interested in providing a data solution. So now the overview part is done. Let's go through individual services in each domain, in each subject area. So first thing first, we talk about data storage. There are 3 different types of storage in AWS. The first is object storage. Object storage basically, and the second is file storage, and third is database. Database is what we call a managed storage. It's managed and organized so that you can easily retrieve the data inside. If you do not retrieve the data, individual data, rather you process them as a whole, this is called object storage. If there's like a picture, photo, I honestly don't want to see which pixel is inside this photo. Rather, I'm more interested in the whole photo file itself. Then this is considered an object. Or if I have a CSV file where it has many data, but in the processing time, I may not need to know which data is inside and which data exists in row 5, column 6. I just want to process the whole file. Then I can consider this as one object. This is what we call object storage. And we also have a file storage. File storage is more related to regular operation, normal operations of a company, like a Word document, PowerPoint slides, or sometimes Excel spreadsheets. So we are not going to cover this part in the presentation. You just need to know they are storage, but it's usually not associated with the data processing. What is most important to data processing is object storage. When the data comes in as files, we will store them as a whole. This usually is a raw data. Then as we start processing, we will split the data, the file, and store them in a more retrievable, more processable, a more analytical way, which is database. So object storage, I'm going to, 1 second, let me bring up so this is a screenshot of what the S3 looks like. There are certain names of my S3 bucket, so I use a screenshot and hide some of the name. But as you can see, there are some bucket called groups and stuff. So basically, object storage S3 is like file storage that you will use on your computer. You just save files in different folders. If I want to create a bucket, I will give it a name. I will choose a region, and I'm going to give it a series of information. Then once the bucket is created, I can just drag and drop files or use a program to write files to this S3 folder. Then it will be there for you to use. There's also something called Glacier. It's archive storage. When we talk about archive storage, it means code. You don't use them. Usually you don't expect to use them. So in this case, you will save this in a cheaper place, but it will take much longer, much more expensive to retrieve the data. So if I have like my tax return 10 years ago, I may save it there. I don't expect to go back to that tax return anymore, but in case I got an audit, I can just go back by retrieving them will cost more. So this is S3 and this is Glacier. You will store the files there. Then we also have a series of databases. As you can see, there are many different databases in AWS. Let me use a present so that you can see clearer. You have a relational database, which includes RDS, Aurora, Redshift, and key value store like DynamoDB. Again, these database types, we just talked about them. They are something that you may be interested in. And they have their specific use cases like high traffic web apps, games, e-commerce systems. You use DynamoDB. For like caching or session management, you use in-memory database. For traditional applications, generic applications, you use relational database. And for something like equipment maintenance, fleet management, high-scale industrial apps, you use white column, etc., etc. Okay. The most important, most popular AWS databases, there are 3 of them: relational database services, RDS, and the DynamoDB and Redshift. RDS is a traditional relational database, including like MySQL, Postgres, Oracle, SQL Server. You probably heard at least one of them. It has a fully management, the version of RDS called Aurora, which is fully managed by AWS. You don't need to worry about like operating on like patches or whatever. And it's ideal for all-purpose processing and generic processing. So let's look at RDS. It's the first under database. So if I open up AWS RDS console, you will see that you can create a database, right? You can create a database, you can create Aurora, you can create MySQL. Let's choose MySQL. And I'm going to provide a series of information, but most important thing is here. You will do a database instance where you will define the CPU and the RAM, basically your compute power, right? So this is a relational database services, just like what you will do in a traditional relational database. You will just create the database on a server, the server with a certain CPU and memory. Another popular AWS database is called DynamoDB. DynamoDB is a key value NoSQL database. So let's go to DynamoDB. It apparently will ask you to create a table, right? So when I create a table, let's say I call it test, and partition here will also be test. I'm creating that. Takes a little bit. And you can see right now there's no item. If I want to create item, you can see there's a key called test. So it will be my key. And I can add values. That's what they call key value. And this is called VB value. And the value would be my value. So this is one item and one item in the database. And you can see something that I already put inside here. So this is a simple key value NoSQL database. It's ideal for fast, schema-less transactional process. And also, there's something called Redshift, which is a large-scale data warehouse. I'm not going to demo that because when you have words associated with large-scale, complex, usually it's expensive, right? So I'm not going to demo that. But if you are familiar with data warehouse, you will know what it is. So these are the database. These are database storage, and these are the object storage. And usually in AWS solution, you don't. The data is not only stored in one place. You actually have a tiered storage structure. So the transactional data may comes in in DynamoDB. But in DynamoDB, you don't want to store historical data. Like after 1 day of processing or 3 days of processing or 1 week of processing, this data is no longer relevant to your current transaction, right? You don't care. In a transactional system, you don't care what someone ordered 7 days ago. Then you probably want to dump the data into S3 for object storage. Then for analytical purpose, you may want to cleanse the data and store it. And maybe when I say cleanse, it means you can, for example, removing the credit card number, to remove the sensitive information like removing the credit card number, and remove the exact street address, just leave the zip code, so that you can do some analysis, like people from certain zip code, how many items are they purchasing, and what's their popular items, right? Eventually, once you are done with this research, you will store data in Glacier for archiving requirements until you don't need to store them anymore. After 10 years, who cares? You will just delete them. So this is a tiered storage where data will come in, stored in certain place for usage. Once they don't need to be stored somewhere, they will be moved down the line until eventually go to archiving place and get removed down the timeline. Okay, so much is the data storage. Once data is stored, well, in order for data to stored, we first need to collect the data. So let's go back to collection. Collection is the process of grabbing data from where it's got generated into your storage system, right? It's from data source to data storage. You may have direct access. For example, Internet of Things. The sensor reading, their Alexa reading, Alexa interactions can be directly dumped into DynamoDB. And if your transactional system is in EC2, you can also use the application to directly write to RDS. This is becoming more and more popular. For example, like if you are a startup and you start a gaming system, you may want just you may want just to directly write from your cell phone clients into DynamoDB. Then the data is collected automatically into AWS. But for companies that has a history of data of their own data, which we call on-premise, you need to move the data into AWS system. How would you do that? One solution is what we call Snow family. It's a physical transportation of data storage device, such as this. It's just a large hard drive that you will plug your cable into your network cable into your company's network and dump data into this device, then ship that back to AWS. It can be as small as a pizza box or can be a semi-truck, which is called snowmobile. So this is easy to understand. It's basically nothing different from a USB drive. There's also something called database migration service and a series of schema conversion tools, data sync. They are fundamental applications running somewhere that they will continuously read your system and dump the new data into AWS over network. So these are two options if you want to move data from your system, your data center, your on-premise system, or other cloud solution into AWS. And for direct access, there's also a trend of using streaming data of Kinesis, which is called Kinesis in AWS, or managed service of Kafka. Kafka is Apache standard, Apache open source standard for streaming data. So what is Kinesis? Kinesis, or managed service of Kafka, MSK, is basically a streaming data that AWS defines some processing buffering power that you can use different tools like EC2 or IoT to dump into this stream, and AWS clients will be able to process them one by one. So let's go back to Kinesis. It's under analytics. For some reason, it's defined under analytics. This is the dynamics Kinesis data stream. If I want to create one, right, you can see we have called test, and you will define the capacity. If I want to have 12, then you can write this much of data into the stream at any given time. Then it will become a pipeline directing the data to wherever you want. You can see there are multiple EC2 instances receiving. You can define the data be directed to all of them, only one of them, only some of them, and it does not necessarily be EC2. It can be other services. It can be directly, you can directly write them to S3. You can use some other like Lambda function to process them, and you can use SQL to pull the information. So these are like streaming data is like these services are providing you with a tool of handling them for this streaming data. And streaming data usually is like what we call continuously coming in, and usually in small size for especially like Alexa or IoT, Internet of Things. Their data usually be small, but comes in continuously. Then Kinesis provides you with a framework where you can read them, process them, and you don't need to handle all the details of this streaming processing. Okay, so we collect the data, we store them, and we need to process them, right? There are many different ways of processing. In the old days, it's like when I was a kid, the nearby department store, they have to process their orders every day. So every day after all the customers leave, they need to sit down, going through the receipts, verify the money is correct, the money level, the money is correct, and then everybody signs up. Then everybody can go home. This one is the traditional way of batch processing, and even with the computer got introduced, it's still the same. For the transactional system, at night they will print out the list how many items are sold, and comparing to the inventory how many items are left. Then the manager need to hold this report and go to the warehouse and make sure the balance, the inventory is correct. This is traditional batch processing, right? You can use EC2 application. Even now, you can use EC2 to host applications in AWS to do the same thing, to calculate every night, do a sum up, calculate the inventory, calculate the flow, the quantity, and providing a new inventory level. There's no problem, no issue. There's no problem with that. The batch processing, one of the batch processing that's got really hot in recent years is what they call EMR, MapReduce Spark, EMR, or Hadoop processing. Hadoop processing, the idea of Hadoop processing is if the processing becomes so complex and it requires a lot of expensive hardware, how about we break it down into smaller, cheaper hardware, like multiple nodes? Instead of one huge expensive node, how about we break this down into multiple smaller nodes? The total processing power is still the same, but the cost will go down because we're using smaller replaceable nodes. This is the idea of Hadoop, and it becomes so successful. It's used in companies like Facebook and Google, and it's becoming so successful that a lot of technology is developed based on this Hadoop Hadoop system or concept of Hadoop. then it becomes an ecosystem where you have a lot of tools that they can work together to form a data processing solution. This and the AWS implementation of Hadoop ecosystem is called EMR. So let me check. This is how you create the EMR. Again, because it's showing my account number, so I use a screenshot and covered it up. But you can see that you have a different EMR release, and you have in the software configuration side, you can see there are different component of the Hadoop ecosystem, and you can pick them. You can pick the Presto ecosystem. You can pick the Spark ecosystem. All these are a small subset of the Hadoop ecosystem, and you can also use your own combination. And finally, in the hardware configuration, you can see that you can choose the instance, what instance you want to use, and how many nodes you want to have. Right now, the default is 3, but 1 is master and 2 core nodes or the computing nodes. You can also have, let's say I put 11, then it will be 1 master and 10 core nodes. All these are configurable. And this, in recent years, is the most popular computing platform in batch processing. We also have, so because Hadoop is so popular, so AWS actually implements its own solution called EMR. And we also have something called Glue, which is the lightweight serverless processing. So let me bring up Glue. For Glue, you can create Glue jobs, which is a Python script that can perform ETL jobs. So right now, let's go to the jobs part, where you can create a job. Right, as you can see here, you can give it a name, use some IAM roles, and use some IAM. That's a security part. How do you control the security? And you can have different types like Spark or streaming or Python shell, and create a script. Then the configuration of this part will have some, will utilize some of the resources in my account. So I'm going to pause it and just present you with the final Glue job once it's created. Okay, so the Glue job is created. And you can see this is just I created a job called test, and you can see that it's just a Python script that you can use if I want to do import, for example, import photo. Oops. 3, and I want to do something like a print hello world. And then when I run it, it will just print hello world to the data stream. But as you can see that if I want to read from database or read from S3 and do some processing, I can do the same thing too, right? So this is the job that the Glue will do. Now if I save it and close it, you can see that inside the job, I have a task job. Each job is a Python script that can perform some ETL jobs, and you can organize the jobs into a workflow for complex processing. You can print hello world and print another thing like hello AWS and print another thing like hello Google. Then you can use the hello world to trigger the other two and form a stream. So this will be done in workflow. If you want to add a workflow, Okay, let me inside here. You can add different oops. You can add triggers, you can add jobs, and form a pipeline. And finally, you can add triggers where you can define like when each job should be started, something like this, right? So you have jobs can be organized into workflow, and you can be started using triggers at a certain time or based upon certain event. And the last part we want to discuss is we talk about Glue EMR, we talk about Glue. And last part we want to discuss is the Lambda. Lambda is a serverless computing where it's defined, you define a function, what we call a function, which is actually a compute unit. It can be triggered by events, right? S3 new object creation, blah, blah, blah. So let me go to Lambda, which is a part of compute solution. You can see that I already created one called display family photos. I'm not going to show you what my family photos. I'm just going to create a function. As you can see, you can use nodes, which is default. You can use Go. You can use AWS, the AWS version of Java and Ruby. So, but we'll use Python here. So I'm going to use test2. So I'm creating that. It's running. And now you can see I have the test. And it's just a bunch of Python code, right? Again, this is just a bunch of Python code. So when you trigger this function, it will run that as a compute unit. It's not going to ask you for a server instead of definition. Remember, when you define RDS, you need to define CPU, memory. For Lambda, you don't need to do that. Neither is Glue. That's why they are called serverless. Or like in EMRs, when you create EMR, remember we need to specify what instance type we need to pick and how many nodes we want to do. But for Glue and Lambda, you don't need to do that. You just need to define the function, and they will run as compute unit on their own when once triggered. And this Lambda, the good thing about it is it can be triggered by events. So if I use the most popular usage of triggering is S3, new object creation, right? So you can see here, whenever there is an object creation event, this Lambda function will be called. So these are the tools that you can utilize in order to process the data. These are like Python script or Ruby code or JavaScript code that you will do for processing. And in order to do data management, there's some tool called lake formation. Lake formation is a recent addition. So I'm not going to cover that, but because it's not stable yet, I think it's still coming up with new features. But this is definitely something you can pay attention to. For now, we can just look at the data catalog of Glue. So data catalog of Glue consists of databases. Once you create it's not actual databases. It's not actual tables. It doesn't store anything. It just lists out what tables you have in your data source. So here, you will define each data set as a table under a database. You will set up connections to a data source, and you will use a crawler to go through the data sources to fetch data definition. If I define a crawler, I want to add, and just call it test again. You can see that you can crawl S3 folders, or you can go to data store. If I choose, for example, data store like JDBC connection, I can connect to the JDBC. For example, I have something called RDS, and I can check what data, what table, what schema I have in this RDS. And eventually, once you pull this over, the information will be defined in the data catalog as database tables. Right now, I only have a default and I don't have any tables. But as you can imagine, if I have RDS, if I have a RDS database, all the tables will be listed here under each database, right? And this is what your data management will begin with. And once you have lake formation, once you implement your lake formation, it will also define the access level, who can access each database table. So it can come from RDS, it can come from Redshift, it can come from S3. You will have a centralized data catalog inside AWS the Glue data catalog, which lists out all the data source you have in your AWS system. That's the beginning of data management. But to be honest, there are a lot more should be done in the data management side in AWS, and I believe AWS is still working on this. So we will see. Maybe in 1 year there will be a lot of more change. And finally, when it comes to the data analysis part, there are many different analysis you can do. First thing is Kinesis data analytics. As we said, Kinesis basically is a tool, a box where your streaming data comes in, and then it flows out to the recipient, to the consumers. While data is inside the stream, however, you can always try to analyze them. Now you have a Kinesis data analytics, right? It's a tool that can help you use SQL query to run against this stream and analyze what's inside. And you can define a time window. I want to see all the data currently in this stream for the past 5 seconds. Then I can run the SQL and see what data has been streaming in. This is very useful when you try to identify a pattern in the stream. Like in Black Friday, in the first 3 hours, what's the #1 item in the last 1 hour, for example, right? Maybe it will switch starting with some electronic device and gradually switch to sneakers and sporting wear, something like this. And you can imagine as the data flows, as time moves, the time windows glides away, you can see the pattern, you can see the change. This is a very important thing in any consumer-oriented data analytics. The next thing you want to see is the EMR processing, because when you think about EMR, it is a Hadoop ecosystem. It's a Hadoop cluster with a one master node and multiple nodes. And each node may have its data. All the data stored on these in situ instances can be used for processing and querying. While you are, of course, the #1 purpose of EMR is to process data, is to get data in, make some analysis, make some processing and cleansing and dump data, eventually dump the data to some persistent storage to where it can save for a longer period. But while the data are inside the EMR node, you may also be able to pull data from EMR to do the analysis, right? It's similar to what we just covered in data analytics, in Kinesis data analytics. Kinesis data analytics analyze the data inside the stream in the pipeline. And EMR, you can run processing and analytics against whatever data currently is in EMR nodes. So these are like a operational analysis. But once data is stored in S3 or in Redshift, you can do complex processing in traditional data warehouse processing, right? This is just for Redshift, it's just traditional data warehouse processing. So there's nothing fancy to talk about. But for data stored in S3, you can also use Athena or Redshift Spectrum to analyze. So Athena is something that you can run a SQL query against the S3 files, which can be very useful. Traditionally, when you have data stored, once you finish processing, data is stored in the data warehouse, and then you run complex query against it. The problem is data warehouse is an expensive solution. Small companies usually cannot afford it. And it's so expensive that you can only have probably like 20% of the data source inside your Redshift, your data warehouse. Of course, this 20% of data source may covers like 90% of your data, but still there are 10% of data that is too expensive. If you want to move all of them inside, it will be too expensive. You won't be able to do it. Athena or Redshift Spectrum provides you with a tool to access external data. That data is not in Redshift. Most likely they are in S3 that you can query against. You can even combine them with what data inside data warehouse. This is what is currently called data lake. Instead of getting data in your well-defined data warehouse, you dump data in the data lake and you query directly against them, which is much cheaper. But of course, with this approach, there comes a downside. Data in data lake is generally dirtier than whatever is in data warehouse, but they are fast. So it's a traditional, it's a balance you need to strike. You need to find a trade-off between the cleanness of data, the usefulness of data, versus the cost. Athena is just a tool, or Redshift Spectrum is just a tool that providing you with access to S3 file. How to utilize that depends on your need. So these are the analytics that you want to run, and there's a AWS QuickSight, which is a visualization tool. Unfortunately, this will cost some subscription, which will cost money, so I'm not going to cover. You just need to know it's a visualization tool that can draw beautiful pictures. How beautiful it is depending on whoever designs that. But then, as we said, a very important addition or a very important front of analytics is artificial intelligence and machine learning. And the AWS has a full group of services created around this part. So I'm going to cancel this Lambda creation, and I'm just going to this machine learning session. Machine learning can have many different aspects. You can have AI services. These are like management service for AWS that's created by AWS, helping you to achieve certain functionality. You have machine learning service, which is the AWS service that help you build your own machine learning platform. So the number one platform, the number one service that we will use is SageMaker. It will help you build and train and deploy your machine learning models. If you have your own tool, like for example, in the COVID-19 pandemic, you want to build a pandemic model on how this virus is spread and what's the different measure that you can implement and what's their effectiveness. You have a SageMaker Studio, you have something like Ground Truth, which will hire people to do it like human laboring. Then you have Data Wrangler to clean up the data or create data features. And there's the feature store, which will sell you the feature that the manufactured by some others. If you have ever touched some data science and machine learning, you will know what feature is. A feature is basically artificially generated data based on raw data. So these are the SageMaker, which helps you with the machine learning. And we also have AI services, such as AWS Kendra, which is intelligent search using different tools. And we have Comprehend. Comprehend is what we call the natural language processing. When someone says something, what's their mode? What's their catchphrase? Like when you talk to someone, is he happy? Is he sad? This is called sentiment analysis. Based on the word he or she used, and based on different phrase, you can pretty much have a guess. Is it positive? Is it negative? This is what Comprehend does. And we have also something like Translate. Of course, everybody knows what Translate does. And then we have like recognition, right? You give a video, you give an image. Is that a cat? Is it a dog? Is it a bear? This is recognition does, image analysis and video analysis. And there's also something like transcribe, translate a speech into text. And or the other side is from the text to speech. And if you think about all this combined together, this is actually what Alexa does, right? You use a transcribe. First of all, of course, you need to get the users. When I say, Alexa, find me a pizza store, Alexa will use transcribe or some similar underlying service, translate this into text. Then it will start analysis of this and identify keywords like pizza. And it may be able to find me if I use Kendra or personalized recommendation, and use this personalized to recommend, oh, there's like a pizza store 5 minutes away from my house. Then it will translate this, use a Polly, translate the text to speech. So that there is a pizza store 5 minutes from your home. So this is a combination of different services that you can use to achieve artificial intelligence. And with this said, we pretty much finished the whole data solution provided by AWS, the key services that you can use and their data flow.